All right, so we're gonna get started, but I'm gonna give you a task to give people some more time to dig in here. We are looking at 6.6, the graphs of secant and cosecant. And if I've got time, I'm gonna go over some of 6.7, just so you see some of the uses of this stuff. I want you to graph good old y equals sine x. But leave yourself some room above and below the graph. More drawing. That's your warm up. You need to look through your lecture notes. Hopefully you have been graphing and you're doing the homework, and you don't need to look through your lecture notes to graph just plain sine x. If you're looking for people to study with and plan on studying, two of our students are at the Mesa Center on Saturdays almost every time from 8 to 12. And they hog an entire board with the trig stuff, and they're going over stuff. They did the unit circle by hand this week. They graphed a whole bunch of problems. They were going through the practice exam. Like, they'll help motivate you to get your shit together if your shit isn't together. And I'll be there to help, but it's on Saturdays. You gotta commit to it, like, if you're not happy with your grades or want to improve is a better way. So help. Alright, so sine starts off at 0 and every pi it has a 0. And in between it goes high then low. So I'm gonna graph a few cycles of these. And we go the other way. There's our good old y equals sine x. Alright, so. Since I started with sine, I guess I'm going cosecant first. I meant to go secant first, but fuck it. So cosecant x is 1 over sine x, right? So we're gonna use that to, it's gonna help us guide our graph. But wherever sine x equals 0. We have a problem. Because cosecant x is then at that point 1 over 0 and it's undefined. So like when sine is pi, it's. Sine is 0, sine of 2 pi. Let's think about. Sine of pi plus 0.001. What does that equal? There's a, I'm going with somewhere here, something here. Sine parentheses shift pi plus 0.001. I'm getting negative 0.00099999. It keeps repeating. Actually, it doesn't keep repeating, it eventually switches to fucking threes. That's confusing. It's showing 6 nines, an 8, and then it goes to fucking threes. How weird. So cosecant of this. Would equal 1 over that. And if I do that, I'm gonna do 1 divided by answer, and I've got negative 1,000,000. Nope, negative 1,000. Negative 1,000 0.167. So when I am just a hair past pi, plus 0.001 is like, we didn't add shit to it. It's at 1,000, negative 1,000, it's completely off the fucking screen. What's happening is everywhere we have a 0 is generating an asymptote. A line that can't be crossed. Everywhere sine equals 0 has an asymptote for cosecant. So I'm gonna pencil those in. Asymptotes, we use dash lines. Hopefully you remember this from algebra. And I'm gonna try to make the one, there's one on the y-axis too, it's a little hard to see. Hopefully you guys can see the slight little bit of red dashes there. And if I did sine of 3 pi/2. Well, I'm gonna say, let's start with cosecant. Cosecant of 3 pi/2 is just 1/sine of 3 pi/2. But what is sine of 3 pi/2? No. 3 pi/2 is on the y-axis.
-1?
It's -1. So 1/-1 is still just -1. So cosecant. I did pi plus 0.00001 and it was way the fuck down here. Like off screen, I can't even put a -1,000 on there. But at 3 pi/2, it was right there. And if I do 2 pi minus 0.0001. We're gonna see that we get the -1,000 again. It's doing some shit like this. This happens on all of them. If you graph sine. And everywhere sine has zeros in it. Before any vertical shift, everywhere sine has zeros in it. That's where your asymptotes are, the red ones, and everything else is gonna look like it's going away from it. So above the graph, it's doing some shit like this. And below the graph, it's going away. So the green is cosecant x. So I'm gonna draw this again from scratch. With that in mind. How I would graph cosecant in general. Cause you gotta see the sine graph to do it. Graphing cosecant x. Graph sine, but very lightly. Or with dots, something like that. Dotted line. So I'm doing every dash is pi again. But either make it very faint, so it's like something you could erase if you're doing pencil, or if you're using pen. We use a little dotted line, because it's not a graphic cosecant. It's just a guideline, a template for how we graph cosecant. That would be step one. Step two. Put asymptotes. Everywhere. Sine of, I'm gonna say b times x minus h. Where this part is a multiple of pi. Or it's called the zeros of sine. You definitely want to do this before your vertical shifts, because the vertical shift is going to change what your zeros look like for sine. In fact, if you move sine graph up enough, it doesn't ever hit zero anywhere, but cosecant will still fuck up. So for that. On the multiples of pi. And then starting at, for step three, starting at each peak or trout or dip. Graph a parabola-like shape. Going away from sine. But not crossing the asymptotes. So at each peak and dip, we're graphing away from it, keeping asymptotes in mind. So this thing has got a funky domain and range. there's a lot of values missing, just like tangent and cotangent have a lot of values missing. Everywhere there's an asymptote is not in the domain. So the domain is all x except where b times x minus h equals n pi. And the range actually has some a closed form that we can write. Range is the y values. We start low, it goes from negative infinity all the way up to 1 and it stops at 1. Including 1. So parentheses for negative infinity, a bracket for -1. Then the graph disappears and starts again at +1, so in union with +1, and it goes up to infinity. What's the period look like? How often does it repeat? Every 2 pi. You kind of want to say pi because there's asymptotes there, but it flips. So like if we go from when we're starting high, it doesn't start a high again until we get to 2 pi again. That's how we graph secant. Same thing, but for cosine. Graph cosine lightly. The asymptotes are where cosine. Bx minus h equals 0. And that happens when b times x minus h cosine is 0 at multiples of pi over 2. And the way to put that into a single thing is 2n plus 1 times pi over 2. And 3 is the same thing. From each peak or dip. Graph a parabolic shape that doesn't cross the asymptotes. Going away from cosine. So give it a try. Try graphing secant X. We just did sin X or cosecant X. So you have a template or a guideline to try to do. Give it a try and then we'll do it together in like 5 minutes. I just realized what you're doing. She takes a picture of the screen, with her phone, and then she looks at her phone. I don't know why you don't move where you can see the screen better.
See most of the words, just like certain, like, um,
You guys are gonna be so sad when December rolls around and finals coming up. And I'm gonna give you homework for winter break. That's gonna go ungraded and I'll never see it. But if you're taking calculus in spring. And you don't practice or review your algebra before you get there. You're gonna get fucked and not in a way that you're gonna enjoy. So like spending winter break, even if you just like once a week. Spend a couple hours going over some algebra shit. You will help yourself so much walking into calculus in spring. And only a few of you will do it, but you'll walk in fresh. I'm grading the calculus one first exam right now and. Most of the points that are being lost are not from not understanding calculus, it's from fucking terrible, absolutely atrocious algebra skills. And fraction work, oh my god. Then Lydia will look at it and Jordan will look at it and Keith will look at it. Cause it's free, I'll put you a website that will, you can look at everything free. I bet Davis will. Hopefully more. Here's my cosine. That's step one, I graphed the cosine version. Everywhere the middle of the graph is, in this case, the zeros, because there is no vertical shift. Putting in asymptotes. And we're gonna graph little parabolas going away from it. And we have secant x. You'll see that we do, once again, have a period of 2 pi. The domain, if I were to list it, would be all x except where b times x minus h equals 2n plus 1 pi over 2. And has the same range as cosecant. Negative infinity to negative 1. In union with 1 to infinity. You guys ready for more? Let's pick it up a notch. Let's do y equals. Let me make sure everyone's ready to do this. I'm getting all twitchy over here.
You're sticking that CO65.
Yeah. I don't think it's scheduled up for spring yet, though. I'm not teaching Calc 1 in spring. Right? Son of a bitch.
Given computer side 1 and 5,
What?
computer side 001 or 005.
I think I'm doing 001. I'll let you know. Actually, I can look it up while you're graphing the next problem. So let's change it up. We'll add something to the amplitude and we're gonna alter our period a little bit first. I have computer science 1, it's an online course. But if you go to the Mesa Center, I'll also be there on the, take it with me.
Is that one like a beginning computer science?
Yeah. Introduction to computer science. They want to have you, the basics in C++. It's good to take about. I just assigned them their first test. Their first test was to program up a. Interview the user, whoever runs the program, interview. Them. Give them like 12 questions, or 8 to 10, it's a bunch of questions. Something they can type in a response and. Ask whatever you want. I didn't tell them what they could ask. I just said, make sure you have to be able to answer every question. As part of your exam, right? It was like, put in what you would answer as a comment. So that was designed to, A, make sure they know how to do commenting, and B, make sure they don't ask some inappropriate shit that they don't wanna answer. I try to make my computer science class stuff fun, the tests. Cause there's a lot of boring exams, but I like to give you. I personalize it, make it your own, do whatever the hell you want. I just need to see that you know how to do these skills. What does our period look like? How do we find the period of cosine? We're gonna start off by graphing y equals 3 cosine of 2x. So what would the period of that be? And how do we get that? That's right,
2 pi divided by 2.
it's 2 pi divided by the 2 from there. So pi. And that means we're probably going from, oop, that would be negative pi over 2. The way I did it. Our period would go from negative pi over 2 to pi over 2. Well. Let's see. Cosine, I gotta put in my 1, not 1, but 3. And negative 3, our amplitude changed a little bit. So cosecant starts off high. And goes down low at the halfway mark and is up high again when the period resets. And period has zeros in between, so this looks like at the pi over 4 and 3 pi over 4 marks. So if I were graphing it, I'm gonna do a little dotted line. Just to see where it is. If you actually just put in the green dots like I did, the zeros, the peaks and the dips. You don't actually even need to put in the dotted line. This dash line is not even necessary. As long as I have those dots, I know where my peak is, I know where my dip is, and I know where my asymptotes are gonna be. My asymptotes will be everywhere there's a zero. If I've graphed this much so far, I don't need to use that weird formula. 2x equals 2n plus 1 pi over 2, that's just awkward. If I've got my cosine graph, I can see what it is. Now we just do our graph going away from the cosine graph. In terms of what I'm looking for on an exam. I'm obviously on an exam. Obviously, I'm looking for the graph. Which is the blue lines. I'm looking for the asymptotes. And labels. Where those zeros are along the x-axis. For at least one full period. I'm also expecting to see. I should see any calculations you made like per period.
Just curious, do we have to have the formula for each of the parabolas?
No.
Hmm.
The formula for the parabolas is the secant, that's the formula. The secant, that's the formula for the parabolas. Like you're not gonna be able to do this individual one. But you should be able to show me like where your period is and then label, notice I have. Negative pi over 4, I didn't label 0, but 0 is kind of obvious. Pi over 4, pi over 2, 3 pi over 4. Pi, this is, I've got enough to show the period at least once. Show where the zeros are.
We don't have to put points on the graph.
You should have these points.
Like the origin points, but not
Yeah,
like
Yeah,
not one
but
or
you're,
two.
where your graph is starting.
Okay.
Let's put that on there too. And the 5 points for each period. The idea is you're not just doing this on a graphing calculator and popping down what you see. You need to show me how it's done, because you're not always gonna have a graphing calculator with you. And shit like that, and let's face it. Graphing calculator doesn't mean you don't know how to do a goddamn thing other than use your calculator. You need to be able to look at a graph and know what you're expecting to see, and if you do it by hand. You'll have an idea of what secant cosecant look like every single time. Let's take a 10-minute break, and then we'll do we'll do a more complicated one with a phase shift in it and the vertical shift. And then we'll look at 6.7 per second, which is not on your test, but it is handy to see what it's for. Look at these fucking kiss asses on fucking chat. Keith and Davis are so full of shit. Esau, good morning, everyone. I hope you guys are excited about doing some PreCalc. Davis says, dude, I'm so pumped. Let's lift these math muscles up then. Let's bring weights to Mesa. Y'all fucking crackheads.
Oh, like, go on.
Alright, let's kick this up a notch. Let's go y equals 1/2 cosecant. Maybe we won't alter the period, but we will shift the graph. So we're gonna start by looking at the sine version. And we're gonna focus on this part. For asymptotes. And then. Do the shifts or the vertical shift. What would the period be? 2 pi, there's no change here. Now, one way of doing this is recognizing the phase shift. Is negative pi over 4. I think this is easier if we say 0 is less or equal to x, x plus pi over 4, which is less or equal to 2 pi. And if we subtract pi over 4 from everywhere. We get negative pi over 4. 2 pi in terms of pi over 4 is 8 pi over 4. So that when I subtract 1, it gets a little bit easier. Subtracting 8 pi over 4 from 8 pi over 4 gives me 7 pi over 4. So I'm gonna do pi over 4 marks. So that's pi over 4. 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. And I'll keep doing more, see what I need for my pattern here. Looks like the graph is gonna be moving up some, so I wanna have a little bit more going upwards. Okay, so sine, we're starting going from negative pi over 4 to 7 pi over 4. And sine starts at 0, so those two are gonna be 0. And the halfway point, which should be 4 pi over 4 steps over. Should also be at 0. And the zeros, so it looks like every 4 of these are my zeros. Those are my asymptotes. Before I pencil anything in, I'm gonna put in my asymptotes. Because they give me my zeros now before the phase shift, or vertical shift. And then I'm gonna do a little side work over here, I'm gonna say. My amplitude is 1/2. So the base graph will have points at. Y equals 1/2 and y equals negative 1/2. And then I'm gonna add in my vertical shift. Plus my vertical shift. Of 2. Or 4 over 2. If I add in 4 over 2, I'm looking at 5 halves and 3 halves. And these will happen at my halfway marks. So my halfway mark between my asymptotes is pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 right there. We need that one. This is 3 pi over 4 for that asymptote and negative pi over 4 for that asymptote. I got my asymptotes marked and where my peak and my dip are gonna be marked. And sine starts medium and goes up. So like the sine graph would start here at 2. And it looks like it's going up to 5 halves. So 5 halves. Right there. And 3 halves is. Right about there. Oh. There. So here I'm gonna do it without penciling in my line. I have my peak here. I've got my asymptotes. And there we go. That make sense? Notice the zeros of where. Like if I had done sign here. Actually, I'm gonna pencil in this sign now that I'm done. Sign would have been like this. It's a relatively flat. Graph, but it should look like a wave and not. Notice my sine graph never hits the x-axis. So y equals 1/2 sine of x plus pi over 4 plus 2 never equals 0. So if I try to graph this and do the asymptotes off this. It never hits 0, so it doesn't work. It's gotta be off just this base graph. Without any vertical shift. And the base graph was down here. So this is the sign without the +2. And this is the sign with +2. So we're going off the base one without any vertical shift. And you put them in lightly. Where and make your graph dark. You can use them as a guideline the whole way. So do the one without the 2 first and then move it up 2 to see where it should go off of. I'm gonna hit stop record and do another video for the next section.